Prepare yourself, because what you are about to read may shake the very foundations of everything you thought you knew about the universe. Almost everything we were taught in school about the Big Bang is no longer correct. And this is not a personal opinion, nor a conspiracy theory. It is a conclusion of modern physics, drawn by the scientists working directly with the deepest theories of space-time, quantum mechanics, and the structure of reality. The most shocking part is this. Most physicists today do not consider the Big Bang to be the beginning of a universe. Let that sink in for a moment. The Big Bang, the event long assumed to be the moment everything began, is not the true point zero of existence. So what exactly was the Big Bang? What actually exploded? Did it emerge from a singularity of infinite density, from nothing, or from something completely different? Stay with me from this moment until the end of the journey, and you will see a picture of the universe unlike anything you have ever imagined. To understand what the Big Bang truly is, we have to go far back in history. Since ancient times, humans have looked up at the night sky and asked, where did all of this come from? The ancient Greeks believed the universe was infinite, eternal, without beginning and without end. Some ancient Indian traditions describe the cosmos as undergoing endless cycles of creation, destruction, and rebirth, like the breathing of a divine being. Then Isaac Newton arrived. In the 17th century, he wrote the Principia and showed for the first time that the laws governing everything on Earth also govern the most distant celestial objects. Newton laid the foundation of classical mechanics, and from that, the foundation of modern scientific thought. But Newton faced a classic problem. If everything attracts everything else through gravity, why does the universe not collapse into a single massive clump? To solve this, Newton argued that the universe must be infinite without a center and perfectly static. No expansion, no collapse, no change, forever frozen. For centuries, this was the dominant view, until something strange appeared. If the universe were infinite and unchanging as Newton imagined, then every direction you look would eventually hit a star or a galaxy. That means the night sky should be blazing bright like the surface of the sun. But instead, we see darkness. This meant Newton's picture had a fatal flaw. People just did not know where the flaw was yet. In 1915, Einstein introduced general relativity. He showed that space and time are not separate entities, but a unified four-dimensional fabric known as space-time. Gravity is not a force pulling objects, but the bending of this fabric. A year later, during a total solar eclipse, scientists observed that starlight passing near the sun was bent exactly as Einstein predicted. His theory became the new foundation. However, Einstein encountered the same issue Newton faced. His equations showed that the universe could not stay still. It must either expand or contract. This frustrated him so much that he added a made-up constant to the equations, the cosmological constant, to force the universe to remain static. Later, he called it the biggest mistake of his life. But was it truly a mistake? We will return to that later. While Einstein struggled with his equations, astronomers who were observing the sky found something revolutionary. Henrietta Leavitt, a brilliant female astronomer, discovered how to measure distances to faint clouds called nebulae. When Edwin Hubble applied her method to the Andromeda Nebula, he found something shocking. It was not part of the Milky Way. It was an entirely separate galaxy nearly 1 million light-years away. Instantly, the size of the universe expanded by millions of times. But Hubble did not stop there. He observed that almost every galaxy is moving away from us, and the farther a galaxy is, the faster it recedes. This could only mean one thing. Space itself is expanding. The static universe was dead. If the universe is expanding now, wind the clock backward. Everything becomes closer, denser, hotter. Eventually, all matter, energy, and space are compressed into an extremely dense state that the physicist Georges Lemaitre called the primordial atom. This is a familiar schoolbook image. The Big Bang begins from a singularity, a point of infinite density where all known laws break down. Hawking and Penrose even proved mathematically that such a singularity was unavoidable. So that is the end of the story, right? No. When we examine the universe more carefully, the classical Big Bang with its singularity began to fall apart. First, the cosmic microwave background, the faint afterglow of the early universe, has nearly the same temperature everywhere. But regions on opposite sides of the universe could never have interacted or exchanged heat. There was simply not enough time. So why are they so identical? Second, space can be curved or flat. When we measure the curvature, we find the universe is almost perfectly flat, balanced with unbelievable precision, like a pencil standing upright on its tip. It seems absurdly fine-tuned. Third, high-energy physics suggests the early universe should have produced huge numbers of magnetic monopoles, particles with only one magnetic pole. But after more than a century of searching, we have not found a single one. These three issues struck at the heart of the traditional Big Bang model. In 1980, physicist Alan Guth began thinking about delayed phase transitions, where something becomes supercooled without changing state. He wondered, what if the early universe fell into a supercooled vacuum state, a special kind of empty space with high energy? When he put this idea into the equations, the result astonished him. In a tiny fraction of a second, the universe could expand faster than anything ever observed. Not normal expansion, but ballooning in size by an unimaginable factor, multiplying its scale by trillions of trillions almost instantly. Guth called this period cosmic inflation. Inflation immediately solved all three major problems. It made the universe flat by stretching it out like a gigantic balloon. It allowed distant regions to have once been close enough to share the same temperature, and it prevented monopoles from forming. But more than that, inflation created the seeds of all structure. Tiny quantum fluctuations in the inflation field were stretched out and frozen into slight density differences. Tiny spots of more matter here, less matter there. These became the foundations of galaxies, stars, planets, and eventually life itself. Without these quantum ripples, the universe would be perfectly smooth, with no galaxies and no life. Inflation is the mechanism that made everything possible. So what is the Big Bang really, if not the beginning? Here is the key insight. In modern cosmology, the Big Bang was not the birth of the universe, but the moment inflation ended. Imagine this. In the beginning, there was empty space filled with a field of energy, the inflation field. This field caused space to expand at an insane rate. Eventually, it decayed, and all its energy transformed into matter, radiation, particles, and light. The moment this energy transformed into matter is what we have mistakenly called the Big Bang. The Big Bang was not the beginning, but a phase transition, a release of energy from empty space. No singularity required. No infinities. Inflation ends only in certain regions. In those regions, the field collapses and forms bubble universes like our own. But outside those bubbles, inflation continues forever, creating more and more bubbles. This is the origin of the multiverse. Each bubble could have different physical constants, different laws of physics, even different spatial geometries. We are simply living in one bubble, in a vast cosmic sea. The only thing we know for certain is that the hot Big Bang happened. We see it in the cosmic microwave background, in the abundance of hydrogen and helium, in the expansion of space. But what happened before the hot phase, why inflation existed, and where everything came from remain profound mysteries. As Alan Guth said, the Big Bang has never been a theory about the bang. It has only been a theory about what happened after. Today, we stand at the boundary between what science understands and what still lies in darkness. We know more than ever, yet we are still far from the full truth. So the next time someone says the Big Bang was the beginning of everything, you will know something deeper. The Big Bang was not the beginning. It was a transformation, a phase change in empty space that gave rise to everything in the universe.